Hi everyone. In this live session, we are going to learn something new. That's how to find the weight. What is the weight of something given to you? If it is a cement block or is a cylinder or it's an aluminum block or anything. It's a water tanker or anything. So it's not about the physical human structure, what we are talking about here. We are talking about the non-living things which gains weight and which has volume, which has capacity. And in this one, the question like this looks a little bit daunting, but it's not. It's super simple and you can solve it in just seconds. So the question one here says the figure above shows a cement block of 36 by 20 by 9 centimeters with two 10 by 8 centimeters openings. Now you just have to understand the question first. The figure shows, this is the figure that shows a cement block. Yes, this is a cement block of 36 by 20 by 9 centimeters. This is 36. The length, the height is 20 centimeters and the width of the block is 9 centimeters. So with two 10 by 8 centimeters openings, these are the openings. That is 10 by 8. 10 centimeters is the length and 8 centimeters is the height. And what is the width for this openings as well? It is 9 centimeters. That's what you have to understand. This block also has a width of 9 centimeters. Okay, what is the weight of the cement block to the nearest gram? The density of the cement is given to you, that is 1.7 grams per cubic centimeters. Now, what is the weight of the cement block to the nearest gram? First of all, we need to find the volume of what is this? What is the volume of the cement block? How much it can hold? What is the weight? So we can find out the weight easily. So what is the volume of the cement block? So we're going to find out that. So volume is naturally, it's really multiplying length, width into height. That's it, nothing else, nothing hard. So you multiply length, width and height. That's 36 multiplied by 20 multiplied by 9. That gives you the volume of this cement block, but you have to subtract the holes which are there. This is hollow, so you have to subtract this part. And what is the area of that part? That is 10 by 8 minus, and how many hollows you have, how many holes you have. So you have to subtract both. So minus 2 into, we have 2 holes. And what is the area of each of the hole? That's 10 into 8, that is length into height. What about the width? How much hollow it is? That is 9 centimeters. We're going to multiply that. That's length, width, length into height into width. Absolutely, as we have done here, length into width into height. Same way we have done length into width into height for this hollow shape also, and there are 2, so we multiplied it with 2. So now we are going to just solve for this. So you're going to get 5040 cubic centimeters. Okay, now the weight of the cement block. They're asking you the weight of the cement block. That's, you have been given density. So weight is nothing but density into volume, nothing else. Density into volume, density is 1.7 multiplied by volume is 5040. That's it. And you'll get your answer. 5040 multiplied by 1.7, that's 8568 grams. And your option is D. Okay, so I hope you all understood this and it was super easy. Let's move on to question number 2. If you like these questions, please don't forget to like, share, subscribe, share it with your friends. Okay, so question number 2 here says the figure above shows an aluminum block of 10 by 8 by 12. That this is what is given to you: 10, length, height, and the width. So 10 by 8 into 12, and with an 8, 6 and 12 inch, that is 8, 6 and again 12 inch opening. What is the weight of the aluminum block? So you can even say, you can interchange and say this is width and this is height, nothing matters. With an 8, 6 and 12 inch opening, what is the weight of the aluminum block to the nearest pound? The density is given to you as 0.098. And it's super simple. How we have done for the first question, we're going to do for the second question also the same way. Nothing changes, no changes, only the changes are in the volume. I mean the numbers, that's it. So volume of this aluminium block, so we're going to find the volume of this aluminium block. That's 10 into 8 into 12, length into width into height. Yes, minus, there's one hollow, there's one hole. What is the area of that hole? Now here we don't have 2, so we don't need to multiply anything by 2. We are subtracting this because it's a hollow shape, it's hollow, so we need to subtract this area. So this area is minus 8 into 6 into 12. We are not going to multiply by 2 because there's only one hollow, that's it. So now the volume is 10 into 8 into 12 minus 8 into 6 into 12. That will give you 384 inches cube, because they are all in inches. Inches into inches into inches. So we have cubic inches. Okay. So weight of the aluminium block will be simple, density into volume. That's what we have learned. So what is our density? 0.098 lb per inches cube multiplied by 384. All right, I need to also have lb per inches cube so that you understand. Here we have inches cube, and that will be equal to inches cube. That gets cancelled out. You're left with lb here. So I'm going to get the weight in pounds. That's 0.098 multiplied by 384 will give you 37.632 lbs. That's equal to option B, 37.6 round off, you'll get 38. Simple, super simple, nothing else. Okay, let's move on to question number 3. Okay, question number 3 here says, a manufacturing company produces cardboard boxes by cutting out square corners 3 by 3 inches. This is the one. By 2x plus 2 inches. Okay, this hole is 2x plus 2 inches. The cardboard is then folded along the dashed line to form a box without a top. If the volume of the box is 162 cubic inches, what is the dimension of the original cardboard before cutting out its square corners? So you have been given 4 choices. You can pause the video as well and you can try it yourself and then check out the answers. But this looks like, oh, what are we going to do? But it's super simple. After knowing the answer, you're going to say, yes, this was actually very, very simple. Okay, let's try to find out the things. So here we have the dimensions of the box. Here it's 3x, here it's 2x plus 2. So we are going to write the dimensions here, the rest of the dimensions. So from here to here it will be 3x minus 6. From here to here it will be 3x minus 6, because as this is 3, this is 3, that makes 3 plus 3 is 6. So if I added 3x minus 6 plus 6 minus 6 plus 6 gets cancelled, and you're back with 3x, the whole length. That's why we have from here to here it's 3x minus 6, and this is 3. Okay, so we have 2x minus 2 the same way here. So what will be this much part from here to here? So you have 2x plus 2 here. So this will be 2x minus 4. Isn't it? If this is 3, if this is 3, you should have your answer as 2x plus 2 the whole length. But if you want only this much part, that means 2x minus 4 plus 3 plus 3. That will make 6, plus 6 minus 4 will give you plus 2, 2x plus 2 back. So the whole length is 2x plus 2. That's how we derive the shorter lengths. Okay, so now the dimensions of the box, I'm going to write that down. That's 3x minus 6 times 2x minus 4 times 3. Because the square corners are cut down, a manufacturing company produces cardboard boxes by cutting out square corners 3 inches by 3 inches from rectangular piece of cardboard. So they have already cut down the 3 by 3 square inches cardboard. Okay, the cardboard is unfolded along the dashed line to form a box without a top if the volume is 162. So we're just going to equate that to volume. Simple. That's made converted into the box. This whole volume, this whole thing is back converted to a box that which has a volume of 162 cubic inches. And that's it. You need to solve for x. So we are going to multiply 3x minus 6 into 2x minus 4. That will give us 6x squared minus 24x plus 24 is equal to 3. This 3 goes this side and it gets divided. 162 divided by 3 will be 54. And so let's bring all the terms one side. That's 6x squared minus 24x plus 24 minus 54 will give you minus 30 equals to 0. And then you have 6 taken out common. You'll be left with x squared minus 4x minus 5 equals to 0. So you have, now when you take out factors for that, 6 goes the other side and becomes, okay, 6 multiplied by, and when you have factors, that will be x minus 5 and x plus 1 equals to 0. So what are the values of x? X is equal to 5 and x is equal to negative 1. So, but here the length of the side is always positive. X is equal to 5, so you're not going to take x is equal to minus 1. So now what are the dimensions of the cardboard, original cardboard? Just multiply them together. That's 3 into 5 inches. 3 into 5, that's 15 inches. And here, that's 2 into x plus 2, 2 into 5 plus 2. That's 10 plus 2, 12 inches. So you have 15 by 12 inches. That's your option C. Simple. Okay guys, so if at all you like this session, please don't forget to like, share and subscribe. Do write it in the comment box. Your comment means a lot to us. And if you want us to take us any particular topic, you can write it in the comment box. Thank you so much guys. Bye bye. Take care.